Hi, everybody. Just wanted to go over the answers that I put down for lesson 1.2. Just want to remind you a lot of these questions don't really have right answers yet. I think it'll get a little more firm in terms of what a good answer is later, but right now this is more of an exploration. Anyway, the lessons, as you remember, is on chronotype theory, and we know that your birth month, well, people like to use birth months to predict your chronotype. And whether you got a correct prediction just depends on you. So your answer to question 1A here is going to be a yes or a no, and it just depends on how it went for you. One of my classes got 48% with correct predictions here. So the other one I think had 54%. So your answer just depends on what class you're in. Now, can the information be used to decide if the chronotype theory works? I'd say that our class doesn't represent all college students very well. They're talking about for all college students here. I'm uncomfortable with using that data to make a conclusion about something that's just so big. Anyway, so to the next part here, they ask us to break down the steps of the statistical analysis process. So the first step is just to ask a question, and I just said, can birth month predict chronotype? Then they say decide what to measure. Everybody kind of determined birth months and chronotypes. Okay, now I think we're at the place where we have a hypothetical. Yeah, so the hypothetical here is that there's this class where 50 out of students had 26 students with correct predictions. So the 26 out of 50 is 52% for that class, which seems to me to be pretty high. So our summary value on question 2C here is to compute that percentage, and with this hypothetical class, so they got 52%. Now the question is, the last step is whether you think the 52% supports the theory. And I'm not really ready yet to say that it supports it. This is just one class, and they're talking about all college students. Okay, so in the next part, they try to talk about, well, what are the ranges of values that can happen by chance? If you're just lucky, we want to know if that 52% that one class got is really high. So they're asking here, is it possible that people would get correct predictions even if the theory is false? And the answer is yes. Even as you know that broken clocks are right sometimes, but that's not because the clock is working, and predictions are right sometimes, and that doesn't mean that there's some magical thing happening. It just could be just luck. Okay, so then they say, well, what percentage of the time should chronotype guesses be correct if the theory is wrong? And there's 3 chronotypes, so you have a 1 in 3 chance when you guess randomly, and 1 in 3 is 33%. So I think I'd like to see a lot higher than 33%. And of course, 50, to be correct, and 52% does seem a lot higher, but I still don't really know if that could just be luck. So the question is, well, let's use probability to discover what might happen by chance. Now, again, this depends, the outcomes that you get from this part of the activity are going to depend on how things went for your group. So you're going to get different answers than I did here. But when I rolled the 2 dice on this cool simulation, I got 16 that were a 1 or a 2 out of 50. So that's a 1 in 3 chance to get a 1 or 2. So I got 32% of my 50 rolls that came up as a 1 or a 2. So that's right close to 33%, and it's kind of proving that, yeah, it's pure chance, but you'll still get it about 33% of the time. And I said, yeah, that's really close to 33% of the time. And then they asked, well, will we get the same thing if we do it again? And of course, the answer is no, because this is a random process. So we do it 5 times, and now I've run it again, and I'll just show you my outcomes ranging from about 14%. And then in one case, I got 52%. So that was my range. And of course, notice the 52% is exactly what happened in the class. And this is just rolling dice. Sometimes you can win 52% of the time by pure chance. So yeah, that that kind of rules out the chronotype theory a little bit right there. 52% could have been luck. Luck can do that. Next part, they want you to make a dot plot. So here's the dot plot I made for these data. And you can see they go from a little more than 10, maybe 14% here, all the way up to 52%. And right in the middle of all this is that 33% mark. And it'll be a little different for you. 33% doesn't always come up exactly in the middle, but it's because we're not really using very much data here. But going back, I said my smallest was 14 and my biggest was 52. Yeah, and they were quite different. And the dot plot was centered, I said, at 33% because it was. The dot plot tells us what can happen by pure chance. Okay, what is... It tells us the proportion of wins that can happen when there's a 33% chance. Sometimes, again, I can go up to over 50% wins. Here they do the same thing, but with many, many more simulations. We just did 5 simulations here, and here they did hundreds, it looks like. They roll 50 dice, and they just look at the different outcomes. And you get this beautiful bell-shaped distribution, which is sort of interesting and very common in statistics, and the reasons for that, maybe we'll talk about later, why it always comes out bell-shaped like that. So we got a 52%, and then how does that 52% compare to the ones in the simulation? Well, I do see that one time out of these hundreds of events here, one time they got a 52%. One time they got 62%, but I'm okay with saying that the 52% is pretty rare, but it still can happen by chance, and clearly you can actually get a lot higher than that by pure chance. Okay, so I'd say the 52% is higher than most of the values that happened by chance. But the question is the 52% convincing evidence that the theory is reasonable? I just said not really. It's high, but there are higher outcomes that did occur by chance. This means that what we observed could just have been lucky. So there's that. I'll just zip past all of this. They ask you to do the steps for the statistical analysis again. So this is one with the fertility clinic where the researchers wanted to know if fewer than half of the women who visit the clinic would want to determine the sex of their child. And of course, that's the question that they're trying to ask. What to measure? They just asked women if they would choose the sex of their future child. And then summarizing the data is usually just to provide that statistic, the 41% said they would. And drawing the conclusions, the researchers concluded that that was convincing evidence that fewer than half of the women who visited the clinic would choose the sex of a future child. Okay. The rest of this is just summary. I'm going to leave you guys to that and conclude the recording here.